This is an EP valve. They're used on Class 50s for driving some of the larger electromechanical equipment, particularly things like contactors, and they operate by passing an electrical signal through the coil here, which is the black piece you're looking at, and that actuates this lever on the top, and that then moves a shuttle valve inside this assembly here, which changes the air path between those three ports. You can see in a vertical line in the middle. Now, they quite often fail because seals go, but once they've had new seals in, they can be reliable for many years. But we have a set of spares which are in unknown condition, so I'm spending this lockdown period trying to bring them all up to a standard where A, we know what condition they're in, but also that we can reliably use those that we want to, and repair those that I can to bring them up to a standard that we can use them in the future. So I have a test rig, and I'll show you that in a minute. So here is my test rig. It has an air supply, which is the blue pipes that you can see, and electrical control switch, which you can just about see in the bottom of the picture down here, and two gauges at the top which tell me which ports are getting pressure. So this particular valve is suspect, so the first thing I'm going to do is I'm going to turn on the air supply, and hopefully we will see neither meter move. But if we can hear rushing air or the meters move in this de-energized position, then it's a faulty valve and we'll have to repair it. So if I turn on the supply, well, that's not good news because I can hear it leaking past already, and you can see there that it's on the gauges, it's already moved. If I operate it manually, it's still leaking even in manual bypass. So okay, well that seems to have settled it, but let's see whether it now operates when I flick the switch. Well, that's not good news. I think the valve is probably stuck somehow. So, right, need to take it apart and have a play with it. Okay, so here it is taken apart. You can see from the amount of dust and rust that's fallen off it that it wasn't in good condition, and much of that actually came from inside it. So I think this one needs a serious rebuild and quite a lot of spare parts. You can actually see that some of the seals, particularly this one here at the top of the picture, you can see how that's just cracked apart. It's absolutely brittle, so that was no longer sealing. I suspect that the shuttle, which is the black item with the fins on it, is probably also deteriorated, and that might be a bit brittle and not sealing properly either. And as you can see, the other end was no better. Generally, there seems to be a lot of material build up on the on all the working surfaces as well, so this is going to need some serious cleaning up, and I'll probably have to replace several pieces. Fortunately, we have a good collection of spare parts, so I'll crack on with that, and hopefully when it's rebuilt I'll be able to put it onto test. So this is the manual guide for overhauling an EP valve. So you can see that it covers the English Electric NV8, which is what we have, but also their replacement by GEC, the 33MV. The GEC 33MV is available in a metric and an imperial arrangement, both of which actually fit. The only real difference is the electrical connections, which are M5s as opposed to 2BAs, but the same wire connections fit. This guide includes quite a useful exploded diagram of the valve, which hopefully will help you see how it works. So I'll just turn to the right page and then I'll be back with you. Right, on the left hand side page there you can see the exploded view showing how all the parts fit together. And then at the top of the page opposite you can see a section view which shows you how the springs fit inside the assembly and can see the lever at the top and how that is then attracted to the magnet, which is to the left hand side, and how that then operates the valve. And there you go, slightly different cutaway version showing it part assembled. The EP valve is here. You can see it has the electrical connections made, and it has an air feed too, and I have 2 meters that will show me the air pressures. So we'll turn the air on and make sure there's no leak. Can't hear any leak, but that was a shotgun in the field behind the house. So that's all good. So now we will switch it on. And you can see that the meter has moved on the far side there, and the other one is stationary. Very shortly I think the compressor will kick in. So we'll turn it off. Again, I can't hear any leaks. You can see the pressure's decaying away. And we'll turn it on again. You can see the pressure is building on the far gauge. It's remained 0 on this one. So turn it off. And you can see the pressure is decaying on both gauges. Normally one of those would just be one of those ports from the EP valve would vent straight to atmosphere, so it would decay rather quicker. So I'll do it again. You'll just about see the EP valve move when I turn it on. Very slightly moves, on off. So this one looks to be tested okay.